So this is section 9.5, day 2. And so now we're going to reverse engineer equations for hyperbolas. And so what they're typically going to do is they are going to give you two things. They're going to give you the foci, and they're going to give you the vertices. So for example, they may tell you that the foci are at plus or minus 4, 0. And they tell you the vertices are at plus or minus 3, 0. And we want to find the equation of the hyperbola. So to do that, we need to start by doing what? Just like we did with all the other shapes. Yeah, you got to sketch the picture, guys. Doesn't need to be fancy. Actually, I don't want to even do that. Sorry about that. Doesn't need to be fancy. Just a small picture to organize your information. Plus or minus 3, 0. There's a vertex, and at 4, 0, there's a focus. Negative 3, 0, vertex, negative 4, 0, focus. Clearly, which way is this opening? In the x direction. So it's looking something like that. So since it's opening in the x direction, is it going to be an x squared minus y squared or y squared minus x squared? So we know it's going to be x squared over a squared minus y squared over b squared equals 1. Everybody got that? Okay. So what we're now going to do is our job is to fill in a and b. Well, technically, a squared and b squared is all we really need to fill in. So do we know a from looking at the picture? Yeah, a is how big? A is the distance that you go each direction to the box in the direction that it opens. So that's going to be 3. That's exactly right. Which makes this x squared over 9 minus y squared over b squared equals 1. So now we just have to find b. Do we know b? So this gave us our a. We don't know b, but what do we know? So we do know that c is equal to 4. And we know that c squared is equal to a squared plus b squared. So that gives us 16 equals 9 plus b squared, which makes b squared equal to 7. Do I need to square root that and solve for b? No. Why not? Yeah, we already have b squared, and that's what we're trying to replace. So we just pull the b squared out, and we put 7 in its place, and we're done. There's our equation. Now, this is one place where this section will differ from the same section in math analysis next year, for those of you moving on. Most of the chapter is the same. The only difference is that when you're reverse engineering these, they won't always give you the vertex and a focus, or the focus. Sometimes they will give you the eccentricity that we talked about, or they will give you the equation of the asymptotes, things like that. But in our book, they always just give us the vertex, the vertices, and the foci, excuse me. Okay? So that's it, guys. Those are problems number 18 through 25 right there. Any questions about that?
Parabolas are a squared minus b squared.
No. Ellipses are a squared minus b squared. Yeah, not parabolas. There's no a and b in parabolas. Yeah, but ellipses, yes. Okay, any other questions on those guys? Okay, the last thing that I really want to talk to you about then is I want to talk to you about the problems where they ask you to graph, but now instead of just giving you hyperbolas like last night, they give you the possibility of circles, parabolas, ellipses, or hyperbolas. Okay? All right. So we need to know how to identify these. We talked about this in the previous section 2 days ago, to be specific. So remember that you can identify a parabola by noticing what in the equation? So to identify conics, so parabola, only one variable squared. Either x squared or y squared, not both. Okay, so that's how you know it's going to be a parabola. Now, for the other three, for circles, ellipses, hyperbolas, both variables are squared. So then we have to go and move on and look at something else. So the next thing to look at is whether the x and y squareds are being added or subtracted. These two, x squared and y squared, are added. What happens on hyperbolas? X squared and y squared are subtracted. Okay? So if only one variable is squared, then you know it's a parabola. If x squared and y squared are being subtracted, then you know it's a hyperbola. If x squared and y squared are being added, then we need more information. And what do we look at if they're both being added? Not the constant, but the... Right. Starts with the same letter, but coefficient, right? Very good. We knew what you meant, but we want to get the word right. So, the same coefficients of x squared and y squared, different coefficients. So this is how you can tell at just a glance, guys, what kind of shape it's going to be. Okay? And that's going to become very, very handy because, again, they don't always give it to you in the right form. And not only do they not always give it to you in the right form, sometimes they give it to you in a form that's intentionally trying to mislead you, right? They make it look like a parabola, or they make it look like an ellipse when it's really a parabola, things like that. We saw some of those. So make sure you identify those correctly, and once you identify it, put it into the right form so it matches the equation that you're supposed to be working with. Okay, any questions about any of that? So that's really all there is to the assignment today. Let me get you going on the homework then.